Hey, good afternoon, everyone. So I want to move quickly. We have three great perspectives on using AI across the field of information specifically. Everything we do relates ultimately to data that's placed, stored, managed, and ultimately, hopefully, appropriately disposed of. It's the securing of that data that has always occupied my mind. I've been in information security for about 20 years, and one of the things that we've seen as the data, the sheer quantity of data explodes, and the usage of that data occurs across a number of shared mediums and environments, is that securing it becomes a greater and greater expense, a greater and greater worry, and that happens not just in terms of the end user and your ability to reach your data to make sure that it's safe, but from a corporate or organizational standpoint, the things that we care about are those threats that become increasingly well-sponsored, not just from our competitors in the industry, not just from the kids in the basement that are writing malware, but also from nation states and foreign competitors who are trying to infiltrate your information systems to steal your intellectual property or as simple as, of course, your financial information. But when it comes to the data we create for our organizations, it's that we're particularly concerned about today, and that we're particularly concerned about in this particular time that we live in the 21st century, because no one is more well-funded than our adversaries who are trying to take our data to get ahead of the curve in terms of innovation, research, and development. And so protecting that data becomes a concern that not only your security department, but your board of directors cares about. And there is an increasing zero tolerance for the possibility of something called a data breach, which is going to cost you not just in terms of hard dollars, which I'll talk about in a second, but also a reputation to your organization that is hard to put a value on and also very hard to recover from. But if we look at, from a study that's performed by IBM and Ponemon Institute every single year, we're looking at 2017's numbers, but the average total cost of a data breach for an organization is in the $11.7 million range. Now that incorporates everything just from the loss of the data, the amount of workload for the investigation, the recovery, everything that the organization has to do from a reputation standpoint to recover or try to recover from that, but also the technology and remediation that happens in the years that follow. Because the spending that follows a data breach, whether it's a target or a bank or especially a healthcare organization, and understand this, healthcare organizations have the highest cost related to data breaches of any industry on the planet. So they are the most concerned of all because the data that they are working with is, of course, the most crucial and private to us. So the dollars go up, right? The dollars are a considerable consideration. Here's the next thing. These things called ransomware attacks, where attackers, whether they're competitors or just extortionists, deposit a piece of malware in your company and then encrypt your data and want you to pay money, usually in the form of Bitcoin or some other untraceable currency, to them in order to give it back to you. These are increasing year over year in double digits. In 2017, it was 27%. Moving into 2018, those attacks went up to about 31 to 32%. So more and more people are using this, and what we see is that ransomware kits are readily available on this place we call the dark web, so you have to have zero knowledge of how to do it in order to download it and use it as an attacker, which is what makes these things very, very, very prevalent. We'll cover this in just a moment in more detail. Here's the next thing that's very telling and very concerning. The average time to resolve a malicious insider's attack, so someone who actually works for your organization that is cooperating with an attacker on the outside, whether that is a competitor or, in a lot of cases, a nation state who has put someone there for a very long sort of term project, can take 50 days to identify that, and then you have the HR and legal costs in addition to and on top of the technology cost. The average time to resolve a ransomware attack is 23 days. So imagine the business disruption, imagine medical devices offline for this period, imagine the impact to health, imagine the impact to day-to-day operations, and then imagine how you're going to recover from that as an organization from a reputational standpoint. So how we handled this in the security industry, which is what I come from trying to secure large enterprise organizations that are doing business across the globe, is we were always in a reactive mode where we are following, tracking, investigating, and pursuing attackers to find out what was out there. We were looking for the patient zero, and when we found the patient zero, we would understand everything we could about what they wrote, what they did, how their malware was designed, and then we would build inoculations for that, and we called those things definition files or DAT files or some kind of virus protective mechanisms that we would then deploy to all of our customers to protect them from that virus, malware, or other piece of disruptive code once that patient zero had been found, triaged, and understood. Now, obviously, you can see that process involved in tracking down that patient zero and then understanding their symptoms and then tracking the point of origin and then understanding how to write that effective inoculation is a very time-consuming process, and this is what drives that number of days to resolution up. It's what drives the cost up with data infiltration, data loss, data leakage, whatever it may be. So not only did the people who were protecting you with their software have to go through this process, but once we provided you with that inoculation, your organization doesn't just take what we give them and sort of haphazardly deploy it throughout your organization. You have your internal processes, you have your internal QA, and you have your internal engineering. And they run through their own internal processes before deploying these inoculations to your endpoints, to your devices, whether it is your handheld devices, your computers, your servers, your medical devices, whatever it may be. They test that to ensure it's not going to cause further damage. This cycle of inoculation takes time, and that equates to taking money. So this is how the industry began utilizing this new field of technology called artificial intelligence to help solve this problem. So to risk recapping some very basic things for you, because I know in every session we have a wide variety of knowledge about what AI is for real and where it comes from and what it's for. We can trace it in varying fields of study. A lot of times we've rested at the foot of a man named Alan Turing. And you may, if you ever saw the movie The Imitation Game, he was played on screen by Benedict Cumberbatch. Great movie about Alan Turing and a great movie about how the Allies broke the German Enigma machine and how they effectively used a very early form of mathematical artificial intelligence to build a first computer called the bomb, which was able to break the code and ultimately help us win the war. Now, what happened after that is that we had these great mathematical formulas and algorithms, but what was lacking for about 20 years was the technology, or better said, the affordable technology, the availability of cheap computing, cheap storage, and cheap processing in order to do what AI could promise to do. And what happened was, over the course of the 80s and the 90s, the 2000s, where we are now, you have cloud computing, people like Amazon and Google that made disk storage of data, big data, possible for the first time. And with big data, suddenly we can realize the true power and potential of artificial intelligence, because AI is essentially an algorithm, a formula, or a process that you need to feed data into. So AI is always and only going to be as smart as the amount of data it has to learn from. So what we're seeing then is that guys like Bezos are seeing that this culmination of events, the maturity of the algorithms, the affordability of disk and processing power and cloud computing is making it possible for organizations and businesses and processes, whatever your business may be, whatever the document or information that you create may be, however you want to leverage that, the availability of cheap computing power and storage is making it possible for AI to revolutionize what you are doing. In fact, Bezos says it's a renaissance. He compares it to a golden age, and that there is no institution in the planet that's not going to benefit from this thing called AI or machine learning. On the other side is Sundar over at Google, and he's saying that AI is the equivalent of the discovery of electricity or fire. It will have that level of impact on humanity overall, because we are just beginning to see what is possible with the computing power and the mathematical processing when these two things meet. And in fact, Google has some pretty incredible projects that are going live in real time right now. There's image recognition, so that all of those images that are on the internet, when you do a search for them on Google, Google isn't reading human inputted tags on what that picture is. Google AI is looking at those photos to identify what is in that photo. And not only only can they tell the difference between a man, a woman, between a human and a dog, but they can put that picture in context and tell you probably, to a great extent, what is going on in that photo. So husband and wife fishing at the lake with their golden retriever. It can put context around that photo. That's all done by a machine with no human interaction at all. Natural language understanding allows real-time translation of thousands of languages in real time. You see these devices coming to market now. You speak in your native language into that device. It's translated on the fly to the person you're talking to. That's done without the aid of a human interpreter. And then digital pathology is revolutionizing a lot of what we're doing in medicine, where it's no longer up to the eyes of a practiced or a naive pathologist to look at scan results, x-rays, and determine if that is cancer or not. What you have is AI who has seen billions of photographs or images of cancerous cell and healthy, and can determine the difference between those things better, with greater accuracy and faster, without waiting those 2 weeks for that agonizing call from your doctor. That's all done with AI on the spot. What we're doing now, of course, in defense is obviously concerned about this and interested in it, and what they do is they take this project called Alpha, which utilizes artificial intelligence and puts an AI in charge of a tactical fighter unit, and what we see is that it outperforms human performance in the fighter cockpit to a factor of about 10. And in fact, the human pilots that went against the AI system in this Alpha experiment were freaked out because what they saw was that the AI they were fighting in the simulators seemed to know before them what they were going to do. And that's how predictable human behavior and reactions can be, which is what makes AI very powerful, especially when we apply it to this problem that I'm talking about today, how to secure your data and prevent data leakage or data attacks. So if we take that and understand this is essentially how artificial intelligence with machine learning handles data and tries to make sense of it. So as a human being, you look at this picture and you automatically recognize it is a dog and probably what kind of dog it is. But what we're going to do as with artificial intelligence is train the computer that this is not only a dog, but what kind of a dog it is, and the characteristics or features that make this a dog and the particular breed that it is. We're going to break those features up into subcategories. We're going to assign a numerical value to them. And then not only are we then going to be able to tell the difference between cats and dogs, but we're going to be able to tell the difference between different breeds of cats and dogs, all by measuring the attributes that the AI sees and breaks down from them. So understand this. It is a machine learning function called deep learning or an artificial neural network that is looking at this data and then breaking it down into features. It's looking at this picture and saying, what is it about this picture that makes it unique? And then it's going to look at another picture of a dog and another, and it's going to do that billions of times until it fully understands to a greater degree than you ever will what it is that makes a dog, what it is that makes a breed of dog, that breed of dog, and what it is that distinguishes it from a cat. And then when we're done applying those those mathematical vectors to those characteristics, we can begin to plot them in 3D. And this is what machines are better at than human beings. They're better, they're faster, they're more accurate. And so what we see is we can take all of those different attributes, and each color that you see here in this cube represents not just a different animal, but a different breed of animal. So that AI system, just by looking at a picture, can break up all of those characteristics and define them. Well, this is a cat, this is a dog, but this particular group of dogs are Dachshunds, right? And it's done all mathematically, it's done all in real time, and it's done all on the basis of an algorithm that utilizes widely available processing power and disk storage. Now here's the thing that we're going to do. We're going to take that same principle and we're going to apply it to malware, to malicious code, to viruses that are written either by your competitor that wants to get ahead of you, some sort of threat actor that wants to steal your data on the national stage or the international stage, right? There's state actors that want to take data from all of our industries for one way or another, either to leapfrog us in terms of innovation or to use it in some term of warfare. So all of those kinds of code pieces that are being written around the world, some of them famous, some of them getting on the news, but many more of them never getting to the news, we can look at all of those different pieces of code and we can put them into an AI algorithm that begins to measure them and understand them to a greater degree than we ever can. So what we take out of that equation is that giant loop of research, of finding the patient zero, of studying patient zero, understanding their symptoms, why they're sick, and where that original threat came from before we can then treat it. What we can do through artificial intelligence is actually take the next step in evolution, and we can prevent that attack from happening in the first place. We can predict an attack before it happens, because human behavior, what we see, is much more predictable than any of us would like. And the more that we study different threat actors around the world, whether it is those 15-year-olds in the basement or those threat actors around the world, is if we study enough of them, we can predict their behavior, we can predict their coding habits, and then we can produce code, artificial code, small pieces of the best performing and least resource utilizing pieces of protective software that we can put not just on supercomputers, but also on the wearable tech that all of us have that's monitoring our heart rates and our health, and also those private personal pictures that we have in our homes. And just with that small piece of math, which is what computers are great at, we can predict and prevent those attacks from happening. And we're able to do that without buying servers, without buying tens of millions of dollars of pieces of equipment for our organizations, without funding 25 people for an IT security department, and instead invest that money in what we're doing, in what makes us money, and in propelling the human race forward in innovation and engineering. So that's what I have. I'm going to pass it over to Amy now, who's going to talk to you a little bit more about some use cases with AI.
Great, thank you very much, Chris. I better stand up here, otherwise you guys won't even see me. But my name's Amy Guarino. I'm the COO of Kyndi. We're an explainable AI company out in California. But first I need to share with you, if you'll give me a minute, a proud mom moment. I had a chance to fly out a little bit early to the East Coast, and on Sunday got to see our 25-year-old son run the New York Marathon, and what a thrill. It was his first time, and but it made me think about when I saw Amy speaking this morning, and she was talking about the marathons. We saw him at various points, and then we saw him at the 24-mile mark. He was pretty pooped. But when I asked him afterwards, what were you thinking about? And he said, Mom, all I was thinking about is I had 2 more miles to go. I had 2 more miles to go. And I think her comment about how looking ahead and always being looking ahead, that's what gives you the motivation to go further. So share a little bit about my background. After college, I moved out to California and went to work for IBM, worked there for a long time, and then started doing startups. And I think what I've really benefited from is this ability to always look ahead and see that next new thing. I was there when the internet got started, when software got started. My most recent startup prior to Kyndi was a little company called Marketo. Is anybody familiar with Marketo? Few people, folks. Yeah, I was the 25th employee. It's marketing automation. So in 2009, I joined. We had less than $1 million in revenue. By 2013, we went public. I think we had about 120 million in revenue. I moved to Japan to start Marketo Japan. I came back and we sold the business in 2016 for just under $2 billion to a private equity firm. And about 3 weeks ago, they sold it to Adobe for $5 billion. So, but it really was transforming the way people marketed using technology and really how they addressed sales and marketing. And I had an opportunity to do something different. So I looked and I said, where is that next wave? And clearly it's an artificial intelligence. And so I wanted to share a little bit about what I've learned and what I've seen about how real customers solve real business problems using AI. One of the things we always talked about at Marketo, because even though it was marketing, you don't think it's that kind of pushing the envelope, but we were pushing the envelope. We would always tell customers, think big, start small, but just get going. And that really resonates for me in AI. There's so many people that I talk to that say, oh my goodness, my data's a mess. you know, it seems too hard, it's all these different things, and I, you know, I can see that this is something that is changing all of our lives right now. It's going to continue to change all of our lives. It's changing every part of business. So I would encourage you, not just from a business perspective, but also from a personal perspective for your own careers. Think big, start small, but just get going. And there's a lot of ways that you can just get going. If you haven't been aware of any of the guys in the robotic process automation space, those guys are on fire. So the guys like UiPath or Blue Prism or Automation Anywhere, what they're doing is they're taking kind of low-level tasks that lots of people are doing, and they're automating those processes and really creating some incredible efficiencies. It's AI using machine learning, and it is just amazing. So if you're looking for where are some places in my business where I've got just a lot of people associated with a task, I would encourage you to look there and talk to any of those companies about what can I do to automate that process, because you can get a quick win and a lot of momentum within your business. And you think about something, and an easy example there is taking invoices, and instead of having somebody rekey the invoices into your billing system or your ERP system, you can have this bot that will go ahead and do that for you. And so that's a great place and a way to start. There's another great company out in San Francisco called FigureEight. And what they've done is they've said, you know, a lot of the challenge is not just in figuring out which algorithm do you want to use, because a lot of them are available open source and that capability, but I really need a data set. I've heard a lot of people today talking about I need to have big data sets. So they marry, and you give them a business problem, and they say, we'll help you figure out the right algorithm, the right data set, and we've got people that can help you in terms of implementing this. And so that's a combination, and again, a great way to get started. The work that we do at Kyndi is all around probably a fuzzier area, which is unstructured data or text. And how do I analyze text? We originally got started working with the federal government with defense analysts, and what they were trying to do is look at science and academic type of documents. And so you'd have a very well-educated, advanced person who's maybe an expert in material sciences, maybe they have a language capability, and they would read all this information, they would extract the important entities, so it could be the people, the concepts, the locations, they'd put them into a spreadsheet, they'd answer very specific questions that would allow them to score that work around the level of innovation and the level of maturity so that they could really understand what are some of these technologies that we need to be aware of. So if you can imagine this person, I mean, literally they're sitting there doing this ultimately by hand. And what we've been able to do is give them the ability to ingest those documents, have the system do all of that extraction, to have the system do the scoring, and then they're able to spend the time really focusing on the technologies that are most relevant and most important. So that's, you know, one example. If you think about all the different places in your life where you have to read a lot of information and materials, those are the places that are really, as we think about this marathon and the next couple of miles that are coming ahead, it's unlocking the value in those documents. Some of our other customers are in the pharmaceutical space. And probably a lot of you realize that in pharmaceuticals, or some of you may be in this business, is that so much of the information is very siloed by the different drugs or the different developments or treatments. And what happens is a lot of these scientists, as they go through the process of looking at new opportunities and new treatments, they write up all of these reports, which is great, but very difficult to share. They all may use different terms to mean the same thing. I may call this a finger, I may call it a phalange, who knows what I might call it. But it makes it very difficult then to share that information across the way. By combining different techniques, so it's, deep learning is one of those AI techniques. There's a number of different other techniques. But what we've done is looked at it and said, you need to use different techniques depending on the different kinds of things that you're looking at. So we combine machine learning with natural language processing and then with knowledge graphs to be able to convert the text into mathematical functions. And what that does then, it allows you to understand, or allows the system to understand the context. So it's not just looking for a finger, it's looking for this thing that's attached to your hand that could have a problem. And so therefore it will pull up everything that's related to that. So really, really different way. And again, it's looking forward in showing you what's possible and what are some of the different opportunities. By taking different approaches and using different kinds of AI techniques, you're able to address some of the big challenges that are out there of, one, not everybody has a labeled data set. We sort of joke with some of our colleagues here in Washington and say, wouldn't that be great if the terrorists would give you a labeled data set so you can understand everything that they're doing? That doesn't happen. You get a whole bunch of data and then you've got to be able to extract that. So that's a big issue. It's kind of the small data issue that is challenging this business right now and these technologies. The other area is ontology. I've heard a lot of people talking about building those taxonomies and ontologies. A lot of that's been done by hand. There are some unique approaches and some unique algorithms out there that allow you to actually extract the structure from the data without having to do that by hand. And so that's evolving quite a bit. And then the third area that's really gotten a lot of publicity probably over the last 4 or 5 months is the issue of explainability. As AI has continued to evolve, one of the big concerns is it's getting smarter, the system is helping me make better decisions. As that happens, I need to be able to explain it. If I go and I apply to the bank for a mortgage and I get declined because of this analysis that was done, partly by AI, then in that case, I need to be able to explain from a regulatory reason why that consumer didn't get that loan. If I'm going out and I'm making other business decisions, I had a telecommunications company in Asia contact us, and they were going through some stuff, and they said, well, the reason we called you is because we really needed to explain it. And I said, but in reality, what you're doing is you're doing a bunch of analysis on sensors. You can get away with doing deep learning and machine learning because it's just going to spit out the answer for you. And they said, you don't understand. In our business culture, our management, our leaders are making decisions, and they need to understand why in order to allocate these different resources. So you need to have an explanation. Just being able to get the answer isn't going to cut it. So those are 3 of the big areas. It's kind of small data, ontology, and explainability that we're going to continue to see evolve as we continue to address these real-world problems within AI. Thank you.
Thanks, Chris and Amy, for setting the stage. So after having an overview on machine learning itself and what you can do with it, I'll close the session with one single use case that we did with a customer of ours, just to drill down to the very bottom of it and what happens. So I work for a company called Raytion, which does enterprise search, which is basically Google plus security. Why do I talk about AI and, as the title says, self-learning social media systems? Well, the nice thing it is, search brings along a lot of stuff that helps us dealing with unstructured data, or it already implements several machine learning algorithms. So let me start with a small definition. What is a social media crisis, or commonly known as a shitstorm? Normally, it's a reaction on a positive thing, in our use case or in our example, an ad made by Pepsi with Kendall Jenner, which was supposed to go really big one of the first interactions with a supermodel. Previously, they tended to go for sports persons. And they made a great video. They pitched it on Twitter and Facebook and whatever you can think of. And unfortunately, they got caught in the drawback when some people figured out that the ad looked like some kind of a Black Lives Matter demonstration, which was intentionally, but nowadays, and I learned that vocabulary over here, is called cultural appropriation. Which means white old men take something over that doesn't belong to them. So we started with the advertisement of the advertisement. Before the ad even started, people wrote about it on Twitter and said, well, go ahead, here, have a look at it. Lots of stuff. And after it launched, a different set of people had a look at it. And here comes the bad news. We're not all equal in the face of the internet. I have to ask, who of you is familiar with the name of Bernice King? Great. Of course. Okay, for all of you who don't know Bernice King, she's the daughter of Martin Luther King, who probably you know. Great. And she picked up the subject that this looks like a Black Lives Matter movement. And her tweet, and here the inequality comes in, got picked up by several newspaper reporters who multiplied in the millions. And to cut the long story short, 2 days later they took down the ad and apologized to the general public. More. This is normally something you don't want to happen for your company. So, how ties that into what I was talking about? You can monitor the social media. You can see the mentions of Pepsi, just as a hashtag or as an entity. And, well, it rose, which is not bad in itself. But there is a property of text called sentiment, meaning is it a positive meaning or a negative meaning, which is also transported. And as you can see in the upper graph, from top to bottom, it's changed from being rather positive to really negative. And what you can also see in the lower right are the hashtags that were attached to the Twitters to it. The most prominent being tone deaf, which I had to look up myself, which is tightly engaged with either cultural appropriation or with racism itself. So we did the same thing for a large Italian telecommunication company. What they did, or what they wanted us to do, was they had a Facebook account, which they used for their social media campaigns. They wanted us to have the posts that happened to this Facebook page analyzed in sentiment, and if something out of the ordinary happens, forward that to the social media team to create actions. Actions can be just a pat on the back, hey, great ad campaign. Can also be the management of such a social media crisis, taking down the ad, creating an apology, putting a large check to some non-profit organization. So, text, unstructured information, especially on the internet, has some specific challenges. The first one is not as familiar to you here in this place as it is for us in Europe, non-English language. most of these algorithms for text analysis are developed for English language, as it's just the most widespoken language in the world. Second thing is, especially on the social media, we are not talking about abstracts of hundreds of pages. Twitter cuts off at, it was 140, now it's 280 characters. Facebook is normally not much longer. A special challenge for AI or machine learning is unbalanced input. People who are happy tend to not tell that to their customers or to the company they bought the product from. But if they're unhappy, they just post it wherever they can. We have a lot of typos, abbreviations, and internet slang. And sorry for that. We have irony and sarcasm, where machines are just as bad as persons. So how does that look like if you map it to a search engine? You have your social media, which is just the data source for us. You have a connector, which transports all the information, extracts metadata, does natural language processing, entity extraction, whatever you think of, puts it into a searchable index. And that searchable index is then used by dashboards to provide a view on the ongoing action to your social media team, or, and you might call that by the buzzword bot, a regular process that just sends email if your sentiment crosses the threshold or the other way around. Now, the important thing is here, the internet or text does not stay stable. If you train a model, it will not work 5 years from now. So what you have to regularly do is just retrain your model and apply it to the incoming text. And this is the lower half of it. So still, why a search engine? So all those green boxes already come along with the search engine. They're just inbuilt. Natural languages processing, text extraction. For some search engines, also sentiment analysis, both on document and on single entity level. You have a basic UI, sometimes even with feedback into the search engine itself, which can be used for tagging, for those famous data sets, labeled data sets that we have. And about the red box as well, it just happens to be that I work for a company that is really good at working with connectors and user interfaces. And this is what it would look like. You have your different hashtags. You have a timely graph based upon the different data sources. If you're more interested in one, you can have a drill down. Again, x-axis is time, y-axis is a textual, a numerical representation of sentiment. Can be either very positive, that would be a 1, or very negative, which would be a 0. And if you have a look at the upper right, here goes your alerts, straight to your mailbox and then to your trash folder. So, just to recap on what Chris already showed us a bit, how does this magical machine learning work? The bad news, it's math. The good news, it is kind of understandable. Because in this case, it's a quite old algorithm. It's called a Perceptron, which was built in the 1960s. Not by Alan Turing, but definitely by a coworker of his. So for text, they use a bag of words, which just means you pick a text, you pick a length, and then you just put your tuples of, in this case, length 2 as the features. And each of these bigrams or bywords will result in a 1 or 0. Either it's there or it's not. And now that we have transferred the text into numbers, it's a simple optimization algorithm where you have an error function saying, okay, if I mislabel it, let's say it's a 1. If I rate it correctly, it's a 0. And now you just go over your training set and try to be as slow as possible. Normally, it's not possible to label everything correctly, but you want to have as few mislabels as possible. How do you test that? You train, assign weights, your test set by dividing it in a training set, and you just keep one small portion of the data set over to check whether you were right or wrong. And you do that over and over again to get an average. And what you then get is a so-called confusion matrix, where you have the true value, which you know because it's a labeled set, and you have the output of your algorithm, which is here on the left, detected as positive or detected as negative. And what you want, ideally, is in the diagonal to have a 1, and everywhere else a 0. So for our customer, and this is the main drawback for machine learning, we had a small data set. They labeled 850 Facebook posts. No, they gave us 850 Facebook posts, and they labeled just 160 of them. And, well, we were quite good at detecting negative sentiments, and we were really bad at detecting positive sentiments. Keep in mind, if you have a choice of 2, and you get it right 50% of the time, that means you're guessing, really just guessing. And I was quite unhappy with that. So I downloaded a Twitter dataset from some machine learning challenge, which had 1.6 million tweets, all of them labeled. And I reran the algorithm, and in here it went better. So here we have a detection for positive things, which is about 80%, and a detection for negative things, which is just about the same. It is nearly impossible to reach 100 here, and here I just quote the source of the set. Humans agree just 90% of the time on it. So, what can I tell you about machine learning? It's about reduction of dimensions. We heard that several times already today. Don't train one model for everything. If you know dimensions beforehand, different data sources mean different means of communication, different languages, train different models. Many of the features which are useful for sentiment analysis are already inbuilt into search engines. And the success of these labels largely depends on how good your labeled test set is. Just one last thing. I'm from Germany, so GDPR. Just because you can monitor something doesn't mean you should. Because even the message you are monitoring is bad publicity. Thank you.